Yeah, I started streaming without editing the comments. So now I have the same comments. Trying to combine unlocked and tracked object. Well, I think I'm still working on that, so it's good enough. Now before I can code, I need some music, at least for myself. What shall we put on? Something without... that they don't have that. I'm gonna go here, just run that again along this one. Okay. What was my last problem? Okay, I moved the tracked object from being a base class of tfoo to being a base class of locked tfoo. Which has some benefits and also some the opposite of benefits, disadvantages. Not to mention that it did break compiling, so I guess that's the first thing I have to concentrate on. Error call to implicitly deleted copy constructor. All right. Yeah, okay, I remember. That's where I was. I'm not trying to copy anything here. I'm just trying to use the move constructor. Yet it says it's copying. Split this up. Right, okay, so apparently it's not a move. How could it be? Well, you never know. Yeah, then maybe, I mean, tfoo must have should have a move constructor. I guess it doesn't. That's rude. Tfoo. It's green and I can't jump to it. Really? Yeah, it's just an unlocked. Totally move. So tfoo is an unlocked and this is an unlocked because it's also a tfoo. I'm trying to move that, so this is the move constructor of tfoo, aka the move constructor of threadsafe unlocked, which is that one. So maybe it's this thing here. What do I comment that out? Probably nothing will compile anymore. My comma has to go to expected semicolon. I'm doing a lot of stuff wrong. Oh, okay, so at least now we know. Yeah, it is this part. Original do right lock, that would be calling that. I don't think the right lock is doing anything. Do right lock. It's doing some stuff, but the compiler is not saying it's this line, blah blah blah. Then it's not this line, right? So we return this start this as a const reference. No copying is going on here. I'm pretty sure about that. No copying is going on. No copying is going on. And it returns an unlocked const reference. And we are allowed to cast that to the base class, which is the const reference, because unlocked is derived from T. So no problem with the static cast here. And then we have an const, an L value reference, but a const one. And then I do standard move. Maybe that is the problem. Oh, yes, that is the problem. You cannot change a const reference into an R value reference. Because an R value reference you can change. I need an L value reference without the const. Which means that this thing must return something without the const. Return type of out of line definition. I could have removed const also here, but I didn't. But now it should compile, and it does. Awesome, that is fixed. Cool, 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 cool. So where are we now? Let's go back to, let's say, the test here, test. I think I commented out a few things. Wait a minute. Get diff. Yeah. Moving it to this, making the tracked object the base class of locked t-foo is, I think, the good track. Locked t-foo is passed to unlocked as the first template parameter, and the first template parameter is used as a base class of unlocked. So this unlocked here is that as a base class, which now has tracked object as a base class, but it's using a protected here. So this one is a protected base class of that one. Therefore, now also the base class of that, even though this one is public, tracked object is now the protected base class of unlocked, because it's a base class of unlocked t-foo, which is protected base class of unlocked. While before it was a public base class of t-foo. So I changed tracked object from public to protected. Now we worked around whatever access I needed by adding some class, I think I've got which one, as a friend. But there were problems, so I commented out a few things. Okay, these two, we have to change that back. That's going to be in source, so let's edit it. Threadsafe test. I'll begin with this one. Yeah, that is not going to compile now. You know, before It was a public base class, and tracker is a member function of tracked object. So that was a public base class, and therefore we could access tracker. But now it's protected base class. We cannot call tracker on a protected base class, so this is not going to compile. Yeah, but we needed to compile, so I have to make every member function must be made public again. I guess inside unlocked. Ooh, that's kind of nasty. I feel more and more to move my utils threading tracked object to the threadsafe namespace. It's getting so intertwined with the threadsafe thing, the unlocked stuff, and that it really does not belong anymore in two different Git submodules. Let's begin with that. So I removed it from utils. And I added it here. Hey Len. Utils threading not found, of course, and it's now thread safe. And I think that the thread safe, I mean, I only should be need to include one of them, and I think this one probably. I cannot jump to that now. Let's make C tags again. So object tracker. What is this? Thread safe test. Sorry. Right here. Thread safe object tracker. See, that includes already threadsafe.h. This is super confusing. In which file am I now? In this file or in this file? What the heck? Okay, same error. I moved it, I guess. But I also have to move it. I have to move namespace because it's still in utils, and I want now it has to be moved to threadsafe, of course. So namespace. This is just going to be threadsafe. Yeah, and then I think I'm literally using utils threading somewhere here already. And that's just a comment, but let's fix this too. Typical one should work with threadsafe unlocked, where foo is derived from this. We're talking about this namespace, although it's also a threadsafe. Well, threadsafe. Tracked object, derived from, same thing. This is a forward declaration. That is now also just in threadsafe. Which then means that we can remove this here. Threadsafe. Good. And then we have another one here. That is no longer okay. Yeah, it's just the same namespace, so I can then do it like that. And then in the test itself, don't have a utils threading at all anymore. It's only 2 of them. Okay. Thread safe. Which then completed the namespace move as well. And now I can go to yep, I'm using unlocked here, and I need this unlocked to redefine the tracker of the base class that it inherited through the fact that we are passing a locked default, which is a user class which is derived from tracked object, threadsafe tracked object, which has the member tracker. Do you see what I see? Default tracker takes the same bloody type here as default itself. So it takes default twice now. What? Okay, that's a slight oversight. Well, before I was passing a unlocked base here, which is what I really needed. And then I needed to cast that or something like that. So I changed to this type. And now we have that type twice. So yeah, we don't need the second parameter at all here. We just clean up, clean up, clean up, right? Beautiful. Tfoo tracker is now an object tracker of Tfoo. Things really come together now. And then I can probably fix this one as well, because I also added Tfoo here. It's also no longer required, I bet. Let's first fix this one. So object tracker in threadsafe no longer needs a second parameter because it's just the same thing. We have a track type and a tracked unlocked. They are actually the same thing. It's called track type here. Let's call it track type here as well. And so I'm just going to go for removing that and call this track type. And then we drop the tracked unlock type because this is the only place where it is being used, I bet. This must be track type now. And then the tracked unlocked type becomes just track type. I love it. Things really are collapsing. It becomes easier, simpler and simpler. And that means normally that you're on the right track when that happens. So I think we are completely at the right track here. Yeah, there was another thing, right? Let's simplify that one as well. I thought that I can probably also get rid of this one. I added that too because suddenly I needed it. But if my foo tracker has a tfoo pass, then I already know tfoo through that type. So also this can be simplified. First I need to make sure that object tracker remembers the tfoo, which is the track type, and it does. It's just track type. So we don't need to remember tfoo. And this is also how it is normally done, as in before the threadsafe version, TrackedObject should have the tracker passed as single argument. Yep, so we can delete this as well. Track type is gone. That's the only place where it is being used. So now track type becomes the tracker track type. Correct, that's what it was called. It's a type name. Yeah, that was this track type there. So okay. Simpler and simpler. Now I get in too few template parameters, a redeclaration again. Specialization off. Wait a minute, what is this? This is the redeclaration. We're looking for the redeclaration of tracked object, which is not defined here apparently. Previous one is there. And so this one. Go, 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 go. Yeah, and then here. Tracked type, we don't have that anymore. Something is going wrong. Too many template parameters. Tracked object, no track type. Tracked object, no track type. Still not good. Oh, ouch. Base class has incomplete type. Okay, so that did not work. Hello, David. That's not so good. So I have to go back now to 2 template parameters. Alcohol is not good for you, David. Talking about a headache, I should drink more. I'll get some water. I'll be right back. Ah. Right. So look, the default is not finished yet, because while declaring it, we're instantiating the tracked object template with the default tracker as a template parameter. Which uses like the default tracker is threadsafe object tracker, which tries to get the track type from tracker, where tracker is the thing that we pass to object tracker. That's a threadsafe unlocked of locked foo, and that is, I think, the track type of this unlocked. Do I see that wrong? Yeah, that's here. That would be inside and unlocked. Yeah. Okay, so interesting. Okay, so I understand that locked default is not complete yet, because we start here, and then while we are defining it, we need this, and t is the one that is equal to locked default. So the problem is, I mean, I went from the bottom up, now we go top down. The problem is we're trying to declare class unlocked having an incomplete base class t, where t is the template parameter of unlocked, as declared here. And indeed, that's locked_default. And then you can wonder, well, okay, but then why are we trying to instantiate this template at this point? And the answer is that we need a data type from it, which is the locked_default. It's hardly a good reason. No, we need a lot more than that. By the time I need object tracker, I need track type for the data type and a policy type to create an unlocked base, which I definitely need because I have an unlocked base type by value as a member. There's no way around creating that unlocked base, which we can only get if this one is known. But okay, for that reason I don't really need the track type to be defined. I just need data type and policy type. It would be nice if the track type was already complete at this point, I think. I mean, by the time I need the tracker here. If the tracked type is already complete by the time I need my tracker, my object tracker. Why would that not be possible? So the track type here is my locked_default. I think so. Yeah, so why do I need my object tracker? I need that because that's a bloody base class of locked_default itself. Oh wait, what? No. I hope there was a way around it. No, I'm not so sure. It's very confusing. Very confusing. Very, very, very confusing. And because of my move, I lost my div. So I don't even know what I just changed. Ugh. The changes are in this new file. Yeah, I think I have to add this one back then. That's not something you want to do from your head. I have to re-watch my own stream, I think, to see what I changed. David, I totally remembered that it was you. Why would I call you little Deek if you change your nick to David TSX? Of course I'm gonna call you David. And your last question. I cannot answer that. The advice that I gave people as soon as they ask me, you know, how to become good in, well, anything among C++, is spend a lot of time on it and work very hard. Nothing comes easy. You've got to exhaust yourself every day for decades. That's just how it works. You can't read a book and then understand everything a lot. So I would say, you just begin, you just do it. And in order to be able to keep going for decades, or let's start with 1 decade, you need to be motivated. So find a way to motivate yourself. How that worked for me usually was that I want something, some end product, and then I just begin. No matter if I have absolutely no overview, I don't know what is needed. I just have an end goal and I start working. So the first thing you would do, of course, is like, okay, I want that, but I have no idea how to do that. So you divide it up in a sub problem, and you start working on a sub problem, which is also too complex. So then you start working on a sub problem of a sub problem. And don't stop working because you lose overview or something like that. Of course you lose overview. The first program I wrote, I never finished. Well, that's not true. The first program I wrote, I finished pretty quickly. But at some point, I started the program when I was still a teenager. And from one thing came another, and the program itself was just never finished. I just had to do something else, and then that was too difficult, so I had to do something else, and then that was too difficult, so I had to do something else. And then the end result was that I was always coding. And that's what you need. Yeah, there's no difference between the days for me. The weekend's definitely not different from other days. But I have days like now on Sunday afternoon I go to my parents, and on Monday afternoon I finally go to something social event. And on Tuesday afternoon I also can't code because then I get a visitor and I have to do other stuff. And I'm still looking for one other thing to do in the week. Maybe some evening I go to a chess club or something like that, or maybe another afternoon. And in the morning I sleep. So, yeah, but the rest of the time I don't have anything to do. I don't have a television on purpose. That's a waste of time. So if I am at home, then I don't really have anything else to do than program. Now I always complain that I have a bad memory. I think it was if anyone actually watching, yeah, Code with Risa. Hello, sorry man. Didn't want to ignore you, but so if anyone's actually watching, which was the last class that I changed? Was it object tracker? I think it was object tracker. No, it wasn't. It was tracked object. Yeah, this is the one that I changed last. So this one I just have to add it back, t-foo here, to tracked object. That's a shame, but that worked, so. Or did it? Yeah, I can pass t-foo here because then maybe I can omit passing this one because it's the tracker should always be that, shouldn't it? Maybe you don't need to specify the type of the tracker. That's an interesting idea. But I'm going to go back to t-foo first and then commit what I have. So I have at least something in the database, in the repository. So we're going to change the tracked object back to have a first template parameter that is the tracked object. Type name tracked type, whatever, track type. And then I don't have to use this, I can just use track type here. No, hopefully that was correct. But it wasn't. Huh? Oh boy. Yeah. Oh, wait a minute. What did I do? Oh shit. This is thread safe. No, it is tracked object. Yeah, tracked object. Tracked object. Yeah. Yeah. I just added it in the wrong place. To track type. I should have added track type there. And then I searched for object tracker and added also something, I think. No, because it's not used. I should have looked for tracked object. And then we find this, and we have to add it here. Type name, tracked type. That's better. Now we are back at this error. Okay, let me think. I'm kind of inclined to maybe not pass the tracker here, but that would be completely different from what I do in the utils namespace. You see, it's a cross reference or dependency, dependency. T4 depends on locked T4. And locked T4 depends on T4. So for some mysterious reason it works like this, but you really have to watch out. But I don't think that this is needed, is it? Yeah, well, T4 tracker. I'm using it here. I think tracker returns a reference. Might as well use auto here. Oh, I need a C-red here. Okay, well then I need it. Might as well define it then. Trackers that. I don't really need to pass it here, but if you have to define it, and it's kind of nasty, isn't it? Or I could use maybe a locked tfoo here, for example. Locked tfoo. And then some type, which then gives me the tracker. Nah, it's also not nice. I'll keep it like this. Yeah. Yeah, it's a difficult interface. This can't really decide what is it's the best way to do it. What to do? I need to expose the tracker, however, here. So I think I need this to be another class. So tfoo is an unlocked tracked object. No, it's called that way, tracked object. No, it's not too bad, I think. You just define tfoo and then you define the tracker in a very straightforward way. And then you pass tfoo and tfoo tracker to tracked objects as a base class for the locked version. I just need to define an unlocked tracked object now. And that's going to be a lot like unlocked itself. Where unlocked tracked object. So the locked foo is the first one, which is, let's say, that's the tracked object. I'm using that, I'm calling that tracked type for some reason everywhere. Or am I? I'm calling tfoo the tracked type, no? Yeah, tfoo is a tracked type. Now what is that? This one. It's nothing. It's nothing yet. Well, it's a data type. It was a data type. I have it internally. I'm specifying data types. Jump here and then just search for data type. It's a locked type. Okay. Tracked locked type is the lock type. Whatever. Yeah. And now I'm trying to define unlock tracked object, which then gets the tracked locked type. It's a template parameter. So that's all that there is to it, except that now we can make it public, because here we have, here we have access to the protected members of unlocked, and therefore also to tracked unlocked type. That's the protected base class of unlocked, and then now we have access to it. So I can here do using tracker, was it right? And then the tracker is, yeah, well, whatever. The tracker is really a member function of a base class of unlocked, namely, yeah, well, base class of a base class. But I think this should compile. Okay, error, constraints not satisfied for class template object tracker. Out of nowhere. Out of nowhere. Oh, I see. Yeah. T-foo is now not an unlocked type. It's derived from an unlocked type. So we have to change that into that it must be derived from an unlocked tracked object instead of from an unlocked. Where's the constraint defined? No member named, instantiation template requested here. Is specialization off. I think this line there. So what was my new invention on unlocked track type? Why is it not green? Still not green. Unlock tracked object. Hello. Yeah, okay. Unlock tracked object is not defined yet here. I need a for declaration. Oops. requires clause differs in template redeclaration. Yeah. And that's different from here. So this one should have been something else. Different file. It's a different file. Hey, it compiles. Okay, let me think. Well, I guess it's just finished. Well, not finished, but yeah. That one thing is finished. vi dot source. Yeah, not directory, man. Edit the threadsafe test. So the last thing I did was uncomment that line. And now we can access tracker. So that I fixed that one. And now we have this one still. That did not compile before. Well, did not compile before the last big change. At some point it did compile. Last time it did compile, I hacked it here to the value 666, and then this was 666. So the assert was firing. And hopefully, no, it's still going to assert that. So I just commented this in. I hope it compiles. If not, we fix that. And then it will still assert because it's still going to be 666. But now I did all preparation needed for fixing that. In case anyone wonders, this is not much code, okay? It's just this code, so I can explain that. So what we do is we make an object of type tfoo, which is not accessible because it wraps a locked tfoo, which is the actual struct with our x. And that type is called locked tfoo. That's the actual struct with the x. Tfoo does not give access to the locked tfoo, at least not directly. So we have something, and then we also have a tracker. But the tracker is created at the moment you create the tfoo. The tracker is allocated on the heap. So this address, we get the reference to it, but that never changes. So now you can have people point to this tracker, and then the tracker wraps a pointer that points to the locked tfoo inside this tfoo. But also the tfoo tracker does not give access. The only way to get access is to create an access object. At the moment you do that, for example this one creates a write access type from the tfoo in this case. And now we have access. But Using that write access type, you can write to X. But the moment that this is created, a mutex is locked. So we are now in a critical area that protects concurrent access to X. And now we do something very dirty. We remember in a variable that is outside the scope of our access type. We remember the address. You should not do that, of course. We leave the scope, so now the mutex is unlocked, but we still have the address to the otherwise inaccessible locked tfoo. Now I move the tfoo to another thing, and what should happen is that the pointer wrapped by the tracker is now updated to point to the new tfoo t. Well, that is the locked tfoo inside this new tfoo. And in order to be able to detect if we now point to the new address, I just override the old one. So this just, yeah, well, just moved it, so you should not access it, but I override it with some random value, very random. I used the dices. No, I didn't. And now we use tracker. I could, of course, do the same thing as I did here, but then I have to use tfoo2 because that's now the new tfoo. If you use tfoo2 here to get an access type, then you just access the new X that we moved here, so that will still have the value 1, 2, 3, 4. But I want the tracker to have been automatically updated. Now the tracker also does not give access. You also have to lock the same mutex. So the only way to do that is also create an access type. And this is a const read access type. Where the type now is a member of the tfoo tracker. And yeah, that works like this, and you cannot pass just this. You have to explicitly say that you want to read log it. I explained in the stream yesterday that why that is the case, because it just cannot know if you want to write log it or read log it. So you have to explicitly say so. And then we have access again through the tfoo-r. So if my tracker works, then this X that we get here through this access object is equal to 1, 2, 3, 4. Meaning that the pointer inside my tracker was updated to point to the new tfoo. Still a long story. I bet I lost all my viewers. Oh, wow, 6 viewers. Okay. Well, and then that's the whole thing. Now my prediction is that the tracker is not updated, so the assert is going to fail. Now it compiles, so it's victory 1, and then we'll run it. Oops, it's still called threadsafe test. And indeed, the value is still 666, so the assert failed. Now, that's the last thing for what I have in my description. The description of the video says, this stream trying to combine unlocked and tracked objects. So this is the last thing of that. If this works, then we have a working tracker combined with unlocked, right? So that you have to, the unlocked means that you have to these access objects that you can use, must use actually to access it, and the tracker also still works in a thread-safe way. How are we going to do that? Well, the magic should happen, of course, during this move constructor. At the moment you do this move constructor, the pointer should be updated to point to the new tfoo. So what does this do? Well, this calls the move constructor of tfoo. And the tfoo is an unlocked tracked object. So we call the move constructor of unlocked tracked object. and which is actually containing nothing except giving access to tracker. So that's just going to be the call to the move constructor of unlocked. And the move constructor of unlocked does the following thing. We call the move constructor of t. But that's the first template parameter. I'm gonna jump back first. So that would be this one. We're going to call the move constructor of the tracked object type. Oh, that's the first template argument of the unlocked tracked object. So we jump back again. So that is this one. That's the locked tfoo. So that's the actual struct. So we're going to call the move constructor of the locked tfoo. And then maybe move something. If I replace the int x here with a standard vector, then it would actually do something useful, an actual move instead of just a copy. Okay, we'll jump forward again. So this is going to call the move constructor of unlocked, which is calling the move constructor of locked tfoo. But with what? Well, it's calling do write log on the original unlocked thing. And that is just this class. And that is just this function here. And that causes the only mutex that we have to be locked. I guess I don't really have to go into that function. It's just locking the mutex. Can jump to it though. So depending on what the type is, we get access to the mutex and we call either write log, or we don't do anything when it doesn't have a mutex. Even that is possible. It depends on the policy. So it does do a write log, and then it returns just the current object or the original object here. So the original object is write logged, and then when we get that back, that is casted to a t, and that is a base class of the unlocked, because this unlocked here is derived from t. Yeah. The cast is not really necessary because the compiler would, of course, automatically use the base class if you require that type, but I think it's safer because we have an unlocked and you never know that what we are calling might even accept an unlocked. And I want to be 100% sure that we're working here with the protected T, the locked tfoo. So we cast it to a tfoo reference, and then we move it. That's also a cast to a tfoo R value reference. And then, therefore, we will call the move constructor. So now we lock the mutex, and then we copy the locked tfoo. So we access the locked tfoo at the moment that it is locked. That's the correct thing to do. And then when we're done with that, including creating a new mutex and setting the mref for debugging purposes. The new mutex, by the way, is not mentioned here, but it's also a base class of unlocked. And we have this T, but we also have policy mutex. So it's just creating, using the default constructor for the second base class, which contains the mutex, read write mutex or the non-mutex or whatever. And when we're completely done, why are we completely done? Well, because this is the most derived class. Well, is it? Well, it must be, right? So that's why we are completely done. And then we call write unlock on the original. So now it's being copied while it is locked. And that's what I want. And then we do the right unlock here, and then actually we're not really done because this is the base class. It's no longer the most derived class. So this class is not allowed to have any members, because if it had members, then we have already done the unlock here, and only then we are going to move the members of this class. So maybe it would be more clean to do the unlock in the unlocked tracked object here. But since it doesn't have any members, it's, well, I'm going to leave it like this. Let's add a comment. Okay, so it's all nice and dandy, but while we have the stuff locked, we need to update the pointer. Which pointer? So let me see, maybe I'd have to do that here because I don't want to change unlocked itself. Now I think about it. That's rather complicated. If you do not use object tracker, but just use unlocked, then unlocked is the most derived class. It really should be. And then this is correct. And then we still want to have a move constructor. So this move constructor is what we need. Even without the tracking objects or without the tracker and etc. But what I want to do now is automatically update some pointer. It's going to be the new t. So I think that the thing points to t, right? Yeah, of course. So we're creating a new t here, and then as soon as we have that, I need to update the pointer with it. But all while the lock is still locked. So either I have to do it, we have to do it after this construction, or theoretically I could do it before that maybe, but yeah, I might have the pointer to the object already before we even call this, but then we are not locked. If you want to be sure that this lock is taken, then you have to kind of wait until we return from this constructor. AKA we have to do it here. But then I have to change unlocked, and I don't want to, because unlocked itself should not have anything to do with the tracked object, the object tracker. And if you want to do it from the class that is derived from unlocked, our unlocked tracked object, then we need to obtain the lock before that. So I think that what I really need to do is add, at the very least then, a move constructor for unlock that does not lock the mutex. So then I can do the lock here and then call that constructor and then do the unlock also here, including the update of that pointer. So I need to change unlocked anyway then. I'm inclined to add that, but I'm not sure if then it's still an official move constructor. As in, does this stop the compiler from generating a move constructor or not? I don't think it does. I think it's the compiler itself is just going to view this as a constructor that takes 2 arguments. And then if you call it, it's still going to generate a move constructor, I think, with 1 argument. That would be ambiguous then if you call it with just 1 argument. So I don't know. Anyway, if it generates one of its own, that's not going to work. So I don't want that. So we need this signature. Yeah, I'll have to add another one then. It's unfortunate, but true. That's a type. I'm just gonna call it, I don't know, no locking. So if now I pass explicitly no lock as a second argument, then I'll get a move constructor that doesn't do the locking thing. But I want this one to be protected, so you really have to lock. So if you stubborn and you don't want that, then you better do it yourself before you call this, aka from a derived class. So that then must be call those functions, which means that these has to be protected as well. Can no longer be private. Let's move it up so I don't have to use the comment. Yes, so now I can pass that to unlocked base class. If I pass also the no lock. So now where are we? Here. So you can add here a move constructor. And then we call the base class with the right lock result. And I have to pass no lock, right? And the no lock should be inherited from the unlocked base class anyway, so that should work. Unlocked is also, the no lock is also protected, right? Yeah, just, oh, I wrote something wrong. That's a different file. I have to jump to the unlocked first. Yeah, but it's also protected, so that should work. Oops. Yeah, that's what we do now. So now we may have members as well. Okay, Jessica Bolt says, then you're nobody. You're nobody. Yeah. Well, sometimes I'm also somebody. I have times that I'm just, I have no idea what I'm doing really. But as long as it suddenly compiles and then works, then I'm happy. I don't need to understand it. Okay, we're having not done anything really, so we still have a compilation, I hope, and still we don't have a compilation. Use of undeclared identifier no lock. Oh yeah, it's like a constant. I could do this, but no. Don't mention constructor for initialization of tfoo. Suddenly we don't have a default constructor anymore. So tfoo is now an unlocked tracked object. and we lost our default constructor. Let's see, do I need a copy constructor? I think unlock does not have a copy constructor. Oh, this one. Oh boy. I think we just need everything from unlocked, except maybe... Oh, it doesn't matter. It just inherit everything from unlocked. So we're using unlocked, not just tracker, but also all the constructors. So, I don't know. So now we can call the constructors of the base class, and then we have a new one here, which overrides, of course, this one. I mean, yeah, better, right? So that's pretty beautiful that I made that work using base class constructor. But this should still not work, so we still assert here, same place, because of course we didn't still not update our pointer. Where's my move constructor? Here. T4 is being move constructor, which means that the unlocked tracked object is being move constructed, which means that we take a lock and then we move construct unlocked, which does everything else, and lock is still like we want to have it here. So let's begin with now getting our pointer back. The new pointer. Well, the new pointer is something that points to, I don't know, I don't even know. I think that, of course, unlocked is what we point to, right? So this is the type, I mean, because that's what the unlocked is using. Actually, it's the unlocked base, but I think it's, yeah. Let me have a look. So I have a base somewhere. Yeah, this unlocked base type. That's what you really point to. So that would be tracked locked type that we point to. But that should be the same type as what the unlocked base type is being created from. So at the moment that this thing is being created, that's here. It's a tracked unlocked. That's the track type. That's a track type. See, these types are just the same thing. That's very confusing, but I think they are the same thing. Or not. No. This is, no, it's not true. This is a different type. Then we are pointing to a base class. That's the pointer that we store anyway. So I have a pointer to the track locked type, which is the data type of track type. The track type is locked. So that type is actually the same type as that type. Maybe I should add it as a comment. That's very confusing otherwise. Note that track type and unlock type are the same type, but have to be passed really? That's how the hell? Okay, nonsense. Sorry, disregard what I just said. It's not the object tracker. It's the other one, tracked object. Still want to add a comment, I think. Yeah, it's not the same type. No comment required. Yes, to fix me. I think I have to call this function. Set tracked unlocked. Aha, there we are. Now I know what the pointer is that I need to pass. Tracked type. That is this one. That is a template parameter of object tracker. That's tfoo. So I need a pointer to tfoo. Well, why not? I mean, probably need a different pointer, but to begin with, a pointer to tfoo is good enough, I think. Because then we have this one, and then the base class of that is derived from that as the first base class, so actually pointers are the same. I can easily cast this onto that one, or the other way around, but going upwards is easier. So let's do a pointer to tfoo, which is the unlocked tracked object itself. Is it that easy? Is it that easy? Okay, so this pointer. That's the pointer that we need to pass. Created a new unlocked tracked object. Constructed that. And that's the pointer that we have to pass to. What was it called? Set tracked unlocked. Is this already being called somewhere, or it's bloody already being called here? What the hell? Tracked object is doing this. Why? I guess that's okay. Now I think about it. Seems okay. Oh, right. So I didn't have to do the... I wasted time. This function is already being called. It's called from tracked object with the correct type by casting the tracked object to the correct type, which is then going from base class to derived class. So this comment is for the other implementation. I think I can delete this. Yep. So this call happens from a call to the move constructor of tracked object. And unlocked is derived from tracked locked type, which is the first template argument of unlocked tracked object, which is locked tfoo. And then locked tfoo is derived from tracked object, and tracked object has a move thing that calls set tracked unlocked on the tracker. So the tracker, which has a certain type, nobody knows what, but it's here. The object tracker now gets that call. I'm not convinced that is... yeah, that's correct, because this thing here contains that pointer. So I have to update tracked unlocked pointer with whatever we get here. And then we're done. So I did not have to do this thing here. Duh. Let's undo it again. And then I don't need to add that unlocked here either. Sorry, the no lock stuff. Well, okay, I'll leave it in. Maybe someone needs it. I don't. We don't need it here. And then I have to add my comment back. Yeah. So we've fulfilled this requirement. The batch makes sure that that is the case, because the only one that can call it is the tracked object one. What is this one? Might as well move that corner. Yeah, okay. I would like to add an assert here that checks if we are logged. But not all mutexes can do that. And I'm too lazy to check if it is, say, my mutex that can do that. Plus, well, then it wouldn't be checking it in all cases. Okay, so that calls set tracked unlocked. How the hell am I going to implement that? Yep, so we get here and before the core dump. Okay. Now let's have a look at this thing here. This is tracked unlocked base type, which is an unlocked base. And now we have the completely never intended task to change its internal pointer. Which means that I think the base class here, const unlocked base, has that pointer, or it's protected. Oh my god. We have full access. Well, anyway, I want to change mbase. I could have, of course, made it protected, but I'm happy to see that it already is. Takes away some responsibility from the current Carlo. And I can blame my past self. Something goes wrong. Okay, protected, so we are here. Well, that means that, oh, okay, that means that unlocked base has access. Doesn't help us because we didn't derive from unlocked base. But haha, I can do that. You can do that. Unlocked base. So now we have a tracked unlocked base class as well. I don't have to change this class. Because yeah, this is of course does not have a function to change base. Nope, just accessors. Yeah, I refuse to change this, so we're going to derive from it as an extension. Let's use inheritance. New class called unlocked base, as here it was called unlocked. So I think, well, unlocked base then, and then tracked object, and then unlocked base here again. What's in the name? And then we want to use this class instead of unlocked base. But I think it has to be defined, right? Because at the moment that this class is being defined, that must already be defined. So I probably have to put it there or something at the top. This class. Let me just move this up. I think I can also move this one up. Let's just move both up. Why not? Yes, you no longer need the thread safe anyway. Do you have more thread safe things that we don't need? Unlock tracked object. It's like in the same namespace. Good. Now we have a tracked unlocked base type here. That is an unlocked base tracked object, which is derived from unlocked base. But now we have access to. I don't need to define a default constructor. That's what we were using. That's the compiler will generate that for us. Oh wait, I'm not using the default constructor. I'm using this constructor. Well, let's inherit all the constructors. Public using all the constructors of my base class. The only thing we need here is a new function which is going to be exactly the same as this one. Going to call it like that at least. Set tracked unlocked. Which allows us to, whoops, to set a new base pointer. And here we have access because Embase was protected. So no. Protected member of the base class of this base class. And then we can call set tracked unlocked with that new pointer on our new unlocked base tracked object class, which is going to be that one. So now we can just do tracked unlock pointer called on tracked unlock pointer. Okay, what is wrong here? It's not atomic. Does it need to be atomic? No, because we're in a critical area. We must be in a critical area anyway. However, are we always in a dead critical area? Like always, except maybe initial declaration. I'm not convinced, like say that the moment that we access this, write to it, the moment that we construct it, okay, that's, nobody cares about that. But after construction, is this thing never, ever, ever, ever accessed, read or write, without locking that mutex first? And I'm not talking about the underlying pointer of this object, but that one. Or is this nonsense? Yeah, no, I meant to say, I don't mean the object that this underlying pointer is pointing to, because that is protected by the fact that this is the unlocked base. But the pointer itself, I don't think the pointer itself is atomic. Maybe you should make it atomic then. That would be sufficient. But it's not needed unless... Okay, so that object, let me see, when are we using it? I'm going to go from the top of the file. Construction, nobody cares, like I said. What is this? That is construction. That's also construction. Both are construction. And here we are locked. This is called while mutex of track type, whatever, is locked. But track type is a type, so let's say the track type. And that then we're going to use that mutex also for the pointer itself, if possible. Yep, and that's the last thing, and we are rereading it in both cases without having it locked. Definitely not locked because we are getting access here. So, oops. Okay, that's whoa, that's interesting. Oh no, oh no, really? Oh no. What the hell, man? I could have had dinner instead of doing this. At the last moment we run into something that's not going to work. Oh shit. You gotta be kidding me. Okay, no viewers left. Yeah, one maybe. I think I'm going to eat. Let's see if I can say in 2 sentences what is the problem here. The problem is that if one thread is moving our object, then another thread may not get read or write access to it. So we're locking this mutex in the middle of moving it. And while this mutex is locked, calls to these two must block. Unfortunately, the pointer that is being updated here, and that we may not access, not even the pointer, while the mutex is locked, is pointing to the bloody mutex. At least of original. Okay, maybe it is possible. Maybe it is possible. I definitely have to make it atomic. What you can do is we read the atomic pointer. I'm going to make it atomic. We read the pointer. And then no. How can I get access to the mutex? I need the mutex to be part of the tracker. It cannot work otherwise. See, call this. Well, I was going to say we read the atomic pointer and then we use it to try to lock the mutex, and then we find out that we cannot lock it. If we get the lock, then we're done, of course, and then we are the owner of everything, including the pointer. So then we can convert that lock into a rad or a wad without unlocking it again. Now suppose that it is already locked. Then we have a problem, I think. I could use the pointer to try to get a lock, and then we fail. But it could be a normal thing, like another thread just has the lock. So basically we want to block until we can get the lock on that mutex. And that would be if the thing is being moved, or the non-normal case. That would be if the the call to write, do write unlock at the end of the move constructor. But if we are trying to get concurrent access to an object that's being moved, I don't think. Yeah, I still cannot assume that that object is not going to be destructed then. So that makes the pointer that we just read a dangling pointer, possibly. So then as soon as we are able to get the mutex, it can be that the mutex itself is already destructed. Is that possible? So what I want to do is basically block in the destructor of the mutex if another thread is already waiting for it. I don't know how that works. So let's say we block a mutex. We have a mutex. Thread A locks the mutex. Thread B tries to lock the mutex but blocks. And now thread A unlocks the mutex and distors the mutex, while B is still waiting for it. Is that undefined behavior? And then another question is, I guess, is then unlock of a mutex atomic with getting the lock in another thread? Like we never return from the unlock of the mutex until another thread already has it? That's a very difficult question that I never thought about before. I'm going to ask ChatGPT, which also doesn't know it, but it's just fun question. Yeah. Seems to make sense. Hello, Boys Bunny. Starting to get worried about you. You're not starting to become psychotic, are you, Boys Bunny? I mean, I'm so totally open for fantasy, but you must keep track of reality. Otherwise it becomes unhealthy. You just deleted the message. Why? Okay, one of the main reasons for this performance, implementing a pair lock, which where threads acquire the lock in order to do this again. Introduce additional overhead. In many cases, it can actually lead to worse overall performance due to an effect known as convoying. If you need fairness in your threading behavior, you have to implement it yourself. I mean, you will likely have to implement it yourself. What? I was just filling that in without reading. I stopped reading here and I continued with, you will have to implement it yourself. And then I started reading it, and what does it say? Exactly what I thought. Well, that's cool. Use a conditioned variables or other synchronization primitives. Alternatively, you could use a third-party library like the one written by Carlo Wood. No, that's not what it says. That provides a fair lock implementation. But in most cases, the best solution is to try to design your program in such a way that fairness is not a requirement for correctness. Yeah, okay. Very nice. Yeah, deleting the message doesn't change anything about that post. And of course, I cannot see what's going on in your head from a single message. And you've said that kind of thing before. So it could be nothing. The way to not make me worried would be to say, "Oh no, don't worry. I just like to, ramble about multidimensional creatures." But the point that you start telling me that the multidimensional creatures are telling you to do certain things, that's definitely going the wrong way. Oh, we have a scammer. Let me see if I can show that.